Physics second year, electromagnetic induction lesson. In that very important topic, eddy currents and advantages of eddy currents. Sir, what is mean by eddy currents? When large pieces of conductors means here wire or rod is conductor which can allow the electricity and heat are subjected to changing the magnetic flux with time. Here what it changes, sir? Magnetic flux linked with time is changes. Then induced current are produced in a conductor. When magnetic flux is changes, induced currents are produced in a conductor, which makes metal to move in a closed path. That metal is moves in a closed path. These induced currents are called eddy currents. Induced currents are called as eddy currents. Eddy currents means induced currents are called as eddy currents. Induced currents means you can increase the change in magnetic flux. When magnetic flux changes, at the time currents are produced. That currents are called as induced currents. Now, advantages of eddy currents. In these 4 points are there. First point, magnetic braking in trains. Now you can consider only electric trains. In some electric trains, electromagnets are situated above the rails. Here suppose this is the wheels of the train. What are situated, sir? Above the rail, electromagnets are situated. These are electromagnets. Now this is the wheel of the train. In some electric trains, electromagnets are situated above the rails. Rails means wheels of the train. When these are activated, the eddy currents induced in the rails. When these are activated electromagnets, at the time induced currents are in the rails oppose the motion of the train. Eddy currents are activated in the electromagnets which oppose the motion of the wheel of the train. Electromagnetic damping. In some galvanometer, the eddy currents induced in the core which oppose the motion of the coil and bring to rest quickly. Now this is galvanometer beta. At galvanometer is located the core. Core is connected to the coil. When eddy currents are activated in the core at the time which opposes the motion of the coil in the galvanometer and the coil is bring to rest quickly. Which currents are? Eddy currents. In some galvanometer, the eddy currents induced in the core which oppose the motion of the coil and bring to rest quickly. Next, induction furnace. Induction furnace mainly using for the purpose of melts the metal. Here induction furnace used and you can melt the metal. This is induction furnace beta. Furnace. With which purpose we are using, sir? To can melt the metal. In an induction furnace, strong eddy currents are induced in the metallic block. Strong eddy currents are induced in the metallic block. Now this is the metallic block. In the metallic block placed the metal. Due to high resistance of the metal, a large amount of heat is produced and melts the metallic block. Here high resistance of the metallic block. A large amount of heat is produced and melts the metallic block. When metallic block is melted, automatically melts the metal. So in an induction furnace, strong eddy currents are induced in the metallic block. Due to high resistance of the metal, a large amount of heat is produced and melts the metallic block. Last, electric power meter. Now olden days, electric power meter, you can observe it better. Here numbers are visible to you. and downside one metal disc, shiny metal disc is rotated, and two inputs, two outputs, and two wires are outputs. Electric power meter. The shiny metal disc in the electric power meter rotates due to eddy currents. When eddy currents are activated, at the time the shiny metal disc rotates. The electric current can be consumed by using electric power meter. Electric power meter use, and we can consume the electric power, and the electric current can be measured by using of the electric power meter. Now this is important problem from lesson number 7, moving charges and magnetism. Problem: a current of 10 ampere passes through two very long wires held parallel to each other and separated by a distance of 1 meter. What is the force per unit length between them? Here two wires are there, two wires are parallel to each other. First wire to passing of current is I1, second wire to passing of current is I2. Two wires to same current is passing. These two parallel wires are separated by a distance of R value 1 meter. How much current is passing? 10 ampere current is passing through the two wires. Now force is acting on the two wires. At the time magnetic field is produces. F2 force is acting to B1 magnetic field. F1 force is acting to B2 magnetic field is produces. We know current carrying conductor produces the magnetic field. First conductor to passing of current to produces the magnetic field which is acting on the second wire. Second wire to passing of current to produce the magnetic field on the first wire. Here we can find out the force per unit length of a wire. Formula: F by L is equal to mu naught I1 I2 by 2 pi R. Mu naught value 4 pi into 10 to the power of minus 7. 4 pi into 10 to the power of minus 7 into I1 value 10, I2 value 10 ampere by 2 pi R. 2 pi into R value 1 meter. Now 2 pi 1s are 2 pi 2s are 2 pi 1s are 2 pi 2s are 2 into 10 to the power of 7. 10 into 10, 10 square. Minus 7 plus 2, you will get minus 5. So finally force per unit length 2 into 10 to the power of minus 5 Newton per meter.